Today we're going to talk about the composition of functions, and this is a way to combine two functions in a meaningful way. And to explain what this means, I like to talk about my mother-in-law. She is a pediatrician, which is super handy to have on hand when you have small children. And so every once in a while I would call her and I would say, how many milligrams of Motrin am I supposed to give to her? And she would say, well, how much does she weigh? And I'd say, oh, 30 pounds. And then I would hear her thinking and she would mumble, 30 pounds, kilograms, milligrams. So she had learned all these formulas about medicines based on how many kilograms the patient weighs, not based on how many pounds. So she would have to convert my daughter's weight into kilograms before she could tell me how many milligrams of Motrin I could give her. All right. So what she was doing was using two successive functions. Right. So she was taking my 30 pounds and she was putting it through this conversion formula that would give her kilograms. And then she was taking those kilograms and plugging them into a Motrin function that gave her milligrams. All right, so another way to think about what she was doing, she was taking her kilogram function and plugging in 30 pounds, and then she was taking that whole answer and plugging it into the Motrin milligram function. Okay, so that whole kilogram, the K of 30 is inside the big parentheses for the M function. So when you do this, when you plug one function into another function, it's called the composition of those two functions. So let's write down the definition of this. So the composition of F and G. Okay, so the composition of F and G is F of G of X. Okay, so I tried to make those parentheses for F a bit bigger than the G one, so you can see that G of X is sitting inside the parentheses of F of X. All right, and so just like adding, subtracting, multiplying, and dividing have a special symbol associated with them, the symbol for composing two functions is a little circle. It's going to look like we're writing the word fog. All right, but that little circle just means find the composition or find F composed with G. Now it's important to note that it matters what order you say this in, just like with subtraction and division, it matters what order you say it in. So the composition of F and G is different than the composition of G and F. All right, so let's get some practice with this. All right, so I have in blue there the definition of the composition of F and G, and they've given us two functions, F and G, and asked us to find F composed with G and G composed with F. So we'll see here that these are different things when you change the order of the functions. All right, so let's start off with F composed with G. So I'll write that little fog looking thing, and then just translate it into the definition. Okay. Always, 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 when you're doing compositions, you always start with the inside function. So I'm going to take my inside function, which is G of X, and G of X is equal to X plus 5. All right, so I'm going to replace G of X with its formula, X plus 5. All right, so they want me to find F of X plus 5. Okay. And at this point, this is exactly the same thing that we did in an old video when we were learning how to evaluate function notation. They've just pulled out the X in that parentheses and they replaced it with X plus 5. So I'm going to go up to my formula for f of x equals x squared minus 3x, and I'm going to pull out all the x's, x squared minus 3x. Okay, so I've got blank places where the x's used to be, and I'm just going to substitute in that x plus 5. So x plus 5, x plus 5. And this one's got a lot of arithmetic to it to simplify. I've got a binomial that I've got to multiply out, either with the box or by foiling, however you do it. And then I'm also going to, I'm also going to distribute this negative 3. So minus 3x minus 15. All right, so let's multiply out x plus 5 times x plus 5. I'm going to do my first, my outer, my inner, my last. And then the minus 3x minus 15 is just kind of going along for the ride at this point. and then gather up all your like terms. So this is the x squared. How many x's do I have? 5 plus 5 minus 3. That's going to give me plus 7x. And then 25 minus 15 will give me plus 10. All right, and that is my composition, f composed with g. All right, so let's try this the other way. They also asked us to find g composed with f. All right, so g composed with f of x is just going to switch the order of f and g in the definition. So instead of f of g of x, this is going to be g of f of x, where f of x is now the inside function. So I'm going to do the same thing that I did last time. Start on the inside, work your way out. So the inside function this time is f of x, which its formula is x squared minus 3x. And they want me to find g of x squared minus 3x. All right, so again, we're back a couple of videos ago where we're just finding g of something. So go up to the function g of x and copy it over without the x's. So g of x is a very simple function. It's just x plus 5. So replace the x with its window, and then we're just going to put whatever's in that parentheses into our function. So x squared minus 3x plus 5. And this time, I don't even really need those parentheses. I'm just going to get rid of them. And there's not even anything to simplify, really. X squared minus 3x plus 5. All right, so let's find f composed with g for these two functions. F of x is 3 over x minus 2. G of x is 5 over x. Okay, so we're going to write down the definition of f composed with g again. Okay, so this is f as the outside function and g as the inside function. Always start on the inside and work your way out. So inside function is g of x. The formula for g of x is 5 over x. So we're just going to find f of 5 over x. All right, so we're going to go up to the formula for f of x. F of x is a fraction with a 3 on top. X minus 2, I'm going to get rid of the x, minus 2. And wherever the x was is where the red stuff's going. So x minus 2 is now 5 over x minus 2. So we get 3 over 5 over x minus 2. Okay, and that fraction is what we call a complex fraction, where there's a fraction within a fraction, and we never want to leave fractions that way. So we need to simplify this. Let's start by getting a common denominator in the denominator. Too many denominators, we got to get rid of something. So I'm going to think of 2 as being 2 over 1, and I'm going to get it to have a common denominator with the 5 over x. So I'm going to multiply by x over x, so that just down there in the bottom underneath the 3, we'll have the same denominator. So I've got 3 on top, 5 over x minus 2x over x. All right, and then within that denominator, now they have the same denominator. I can put them together with fraction subtraction. So 3 up top. Then on the bottom, I've got 5 minus 2x over the common denominator x. All right, so make sure we got that big bar underneath the 3 so you can see which bar means the big denominator. All right, and then we're just dividing fractions. We've got 3 divided by a fraction. However you learn to do this, keep, change, flip, or we're going to flip the bottom, reciprocal the bottom, and multiply. So we're going to do 3 times the reciprocal, x over 5 minus 2x. And we can just multiply those fractions. Remember that 3 is 3 over 1. And I'm going to get 3x over 5 minus 2x. All right, so for that one, the simplification was worse than the composition of the two functions in the first place. All right, so we'll talk a little bit more about compositions when we meet together in class. See you then.